This is video number 2 for lesson 5, the ideal gas law, for unit 8 on gases. So what we are going to be looking at is variations of the ideal gas law. So these are different versions of it based on putting different variables in and taking things out. So the first one we're going to look at is formula mass, and formula mass is grams per mole, and we're going to be looking at mass. So this version of it, instead of having our moles, we're going to have a mass and a formula mass. So we might not know how many moles we have, but we know what the substance is and how many grams we have. So a capital M is going to stand for our formula mass in grams per mole, and little m is going to stand for mass in grams. So everything else is the same. R is the same, temperature, pressure, volume. So our example problem says, what is the mass of a 75.0 liter sample of argon at STP? There's our STP again. So we're going to write down all of our variables. In this case, we have 6 of them. So STP, standard temperature and pressure. So that means that the pressure is 1.00 atmospheres. We're given a volume of 75.0 liters. We know that argon is our substance, so we can look up the molar mass or formula mass or atomic mass, whatever, of argon, and we see that it's 39.95 grams per mole. Well, we don't know how many grams of this we have, so that's our question mark. Our R value is always the same. And our temperature, STP, is 273 Kelvin. So now all we have to do is put it into our equation. So P, 1.00 atmospheres, times V, 75.0 liters, times capital M, 39.95 grams per mole, is equal to little m, which is our question mark, times R, 0.0821 liters atmosphere per mole Kelvin, times our temperature of 273. So in this case, we have to get little m by itself, so we're going to divide both sides by our R value and T. That crosses these out, leaves us m by itself. All of our units are going to cross out, so atmospheres and liters, and then Kelvin and moles, and it's going to leave us with grams. We need 3 significant figures, so that means that we have 134 grams. So that's one variation of the ideal gas law. So we have one more that you may encounter, and that is PM equals DRT. So we know that P is pressure, capital M is formula mass, R is our universal gas constant, and T is temperature. So D is going to be density in grams per liter. So with this one, here is our problem. We're solving for density of neon gas with our pressure in kilopascals and our temperature in Celsius. So we might have to do a little bit of conversion here. So P, M, D, R, and T. So our pressure is 252.5 kilopascals. Well, it has to be in atmospheres, so we have to change kilopascals to atmospheres. So this goes back to lesson 1, where we have pressure conversions. 4 significant figures, we get 2.492 atmospheres. We have neon, so you have to look up the formula mass of neon, and it's 20.18 grams per mole. So I just got that off of the periodic table. It's asking for density, Our R value is right here. And our temperature is 37.0 degrees Celsius. So we have to convert that into Kelvin by adding our 273, and we get 310 Kelvin. So now that we have all of these values, we have to substitute them into our equation. P M is equal to D times R times our temperature. So since we're solving for density, we need to get density by itself. So we're going to divide both sides by R and T. So in the calculator, 2.492 times 20.18 equals, divided by both of these numbers and three significant figures, we get 1.98 grams per liter, and that is our density.